Hello! NanGate Liberty Analyzer provides a fast and intuitive way to analyze and validate Liberty files. In this video, we will demonstrate part of Liberty Analyzer's feature set. Let's start by talking about library analysis. In normal execution mode, the user provides one or more libraries and Liberty Analyzer creates an HTML databook. In this example, we are providing a single library and asking the tool to generate some plots by using the option -plots. Through the databook, it is possible to quickly explore library at cell, pin, and individual arc levels. For example, by navigating to cell pages, it's possible to inspect point-to-point data. Under the Cells tab in the main page, we can quickly find all the cells available in the library, click on them, and navigate to a cell page. On the start of each cell page, we can find a brief description of the cell, its drive strength, area and logical equation, for instance, and right below, links to detailed cell data. For instance, propagation delay tables at arc level. If we navigate back to the main menu, we can find library level reports, the profilings, and the summaries. Library level reports depict how cell groups are distributed within the library. By condensing library data on a single report, one easily identifies problematic cells. For instance, the inverter X1 has an area much bigger than expected when compared to other cells. If we navigate back to the summaries, instead of finding cells classified in groups, we would find the statistical information about a given metric. Output transition, for instance. We can see that the worst transition time for this N3X2 is around 281 picoseconds. We can also see that the best transition time is around 10 picoseconds. And with 2 clicks, we can navigate to cell level data and find out which arc is causing this worst transition time. In this case, arc A1 to ZN. Liberty Analyzer can also create comparison reports, making it easy to compare libraries from different vendors. When we inspect the databook, apart from our reference and target libraries used in the comparison, we can also see the absolute and relative deviation libraries. In the relative deviation library, we can have a quick overview of how each metric in these 2 different libraries compare to each other. For instance, one can see that the target library is much faster than the reference library, although consuming much more power. We might then decide to navigate back to cell level to inspect the source of these deviations. For instance, power consumption for this NOR3X2. We can see that power consumption is consistently worse as input transition increases through all the arcs. If we click on the plot button, we can also visualize this table on a 3-dimensional graph. Thank you for watching.